So what this means actually is it's a way to cut off this entire curve into segments. Okay. Now, when it comes to the empirical rule and the normal distribution itself, the mean is always at the center. So in other words, always at the middle of the portion. That is your mean. So that's what we're going to symbol our mean itself, right? Mu. Okay. Now, what this means by 68% is if I go up and down by one standard deviation, so if I subtract my mean from one standard deviation and I add standard deviation plus my mean, so I'm up here basically, I guaranteed 68% is going to be within these two numbers. That's what that represents. So it gives you a nice cutoff when it comes to percentages and things like that. So if I go out one more, so if I go out to two standard deviations, so one more here and one below, so now it's your mean minus 2s and your mean plus 2s. What you're guaranteed is 95% of all the data values are going to be within these two numbers. Okay, and then finally, if you go one more out, way out here, and then way out here, so it's plus 3s and minus 3s, you're guaranteed 99.7. So between these two numbers, 99.7, all the data values are between here no matter what. So you still have some, outliers. We talked about outliers before, right? So you can have those portions on the outside. So, the rare case. We'll talk about outliers in a little bit, but sometimes you can't capture all of it. So there's some data values that are not included, right? So that's, very, very little, right? 99.7 is a huge chunk, right? So when it comes to it, but very little is actually calculated when it comes to it. So what this empirical pretty much tells us is I can break up this entire curve into segments. All it is just starting from a mean and just going plus, 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 minus, 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 and slowly breaking it down. Now, the good thing about the empirical rule is these percentages are set in stone, as they are here. So I try to break it down so you can see the certain percentages itself when it comes to it. Okay. So what we want to do when it comes to the empirical rule is, well, what if you give an example, or and want to create it itself? So let's look at this quick little example so you can see what this means when it comes to it. So a bag of chips has a mean mass of 70 grams. So that's our mu, right? Mean is 70. With a standard deviation of 3 grams. So there is our sigma, equaling 3. Assuming normal distribution, create a normal curve including all the necessary values. So in other words, the necessary values is the 7 values here. So 1, 2, 3, 4, 5, 6, 7 values. Okay, and that's what we're going to do here. So remember, it breaks it all up. So we know, right, for sure, our mean is going to be at the center. So this value is 70. Right, that's our exact middle. So now what we want to do is just get the next value when it comes to it. So if it's easier, you just start from left and then you go from the right if you like, or vice versa. So to get the next two values, right, this value here and that value there, what we're going to do is we're going to, our mean, so it's 70, and we're going to plus sigma. So we're going to plus 3, right? So that's what we get here. So it's 70 minus 3, which is this value here, and then 70 plus 3 gives you that value there. Well, 70 minus 3 is 69, or 67, so here's 67. 70 plus 3 is 73. So that's how we get those numbers. So that's how we regenerate these values, right, because it's arbitrary. So then we can do the same thing. So we're going to want one more. So the next value we get is your mean plus 2 times sigma. So it's going to be right here, 70 plus 2 times 3, and 70 minus 2 times 3. So remember, order operations comes first, right, hopefully. So that's going to be 6, right? So it's 70 minus 6 gives you 64. So these are 64. And then 70 plus 6 is 76. So those are our next two values. And then finally, we're going to get a last 3. So that's going to be 3 times 3, and then 3 times 3. Then we just plus and minus. So this is going to be 9. This is 9. So 70 minus 9 is 61. So way out here, and then way up here, 79. And that's how we get that's how they got the values of those to figure it out. Okay. So that's how we use the empirical rule. It's just going to literally break it down and figure out these 7 numbers, and from there we can answer the questions itself. Okay. So why don't we try one over here? Okay. So why don't you guys try this one real quick? So using this example now, go ahead and create your own normal curve and then find the 7 numbers associated. So 3, 2, 1, pause. Okay, so hopefully you guys tried it. So just quickly draw a curve real quick. Right. So at the center is going to be our mean, right? So we have to figure that out. So the finishing times for people completing a half marathon in 2010 were normally distributed with a mean of 130. So we got our mean, 130. So we just write that down. Mu equals 130. Okay. And a standard deviation of 20. So sigma equals 20. Okay. Create a normal curve including all the necessary values. So essentially all 7. So we got 1 down, right, just by knowing the mean. So that's good there. Okay. So now we got to do the other 6. All right, so I need 3 lines here and 3 lines down. Okay. Okay, so how do we get this one? Well, if we follow our example, right, to get the next one, so how they got 73 is they added 1, right? So you add and subtract 1 standard deviation. So in this case, we're going to add, subtract 20. So 130 plus 20 is 150. 130 minus 20 is 110. Right? 2 down, 4 more to go. So now to get this number, well, according to our example here, what they did is now plus 2s minus 2s, right? Because now it's according to our portion. It is plus and minus the same values, right? So this case, to get the numbers here, to the next markers, it's going to be 130 so it'll be 130 plus 2 times 20, and then 130 minus 2 times 20. Right, so this is going to be 40. So 40 plus 130 is 170. So that works there. And then you do the opposite. So 130 minus 40 gives you 90. So this is 90. And then lastly is just 3 of them. Right, so it'll be 130 plus 3 times 20, and then 130 minus 3 times 20. So just doing the math, this should give you 190, and over here should give you 70. And there you go, where you created the bell-shaped curve. Okay. So just for extra added bonus, well, why don't we break this up too? So for example, between this number and this number, what percentage is guaranteed within those 2 numbers, according to the empirical rule? Well, we're 1 standard deviation away, right? So that guarantees exactly 68%. So we know between these 2 numbers, 68% of all the data values are within those 2 numbers. Okay. Let's go farther out. What about between 90 and 170? Well, according to the empirical rule, that means we're 2 standard deviations away. So that guarantees exactly 95%. So we know between 90 and 170, there are 95% of all the data values between those 2 numbers. And finally, the last one, 70 and 190, is 3 standard deviations away, and that automatically is 99.7%. So there we go. There is our curve. And now we can just straight out answer questions from here, right? So some questions will ask you, okay, grade it. Now I'll say, okay, what's the percentage that lie between 90 and 170? Well, you know that's 2 standard deviations away, so accordingly that's going to be 95%. What are the range of values that have 68%? Well, here's 68%. So what are the 2 numbers? 110 and 150. So that's the kind of thing you're going to ask when it comes to the empirical is. Now you construct it now just, using your empirical rule and the percentages being asked you to find those particular ones, okay? So I want to try next one. Let's try a question so you can see when it comes to it. So it said, what if instead the mean was 100? So they changed the mean on us, and the standard deviation now was 15, okay? So the question is, what percentage of people completed the half marathon between 70 and 130 minutes? Now, I'm not sure, right? But this is pretty much your work, right? So I'm just going to redo it here. So I'm just going to get another piece of paper. Okay. So now, using our new mean and new standard deviation, I'm going to do the exact same thing we did on top, where our mean is 100 now. So I'll just go right here. Mean is 100, and sigma is now 15. And I'll do the same thing. Okay, so you can just copy exactly what we did here, but now again it's 115 instead of 130 20. So add 15, subtract 15, right? Next one, I'm going to add 2 times 15, so 30. So that's 130. So, and then subtract 2 times 15, so that's subtract 30. Last one, add 3 times 15, so 45. And same thing, subtract 45. And there's a new bell-shaped curve. So notice I didn't actually answer the question yet, right? All I did was draw my curve, then I can now answer the question from here. So now look at our question. It says, what percentage of people completed the half marathon between 70 and 130? Well, here's 70 and 130. All right, well, how many standard deviations away was that? Well, this is 1, right? And this is 2, so I'm just 2 away. So since I'm 2 standard deviations away, again, according to our empirical rule, that guarantees is what? 95%. So the answer to this question is 95%. So all it is matching the data to the actual rules themselves. Okay. So now if we go to part B, what percentage of people completed the half marathon between 55 and 145? Well, again, over here. Well, we already said this is 1 standard deviation away. We said this is 2 already because we answered part A. Therefore, the way out here is going to be 3 standard deviations away. So according to the empirical rule, the last rule, right, that guarantees us 99.7%.